All right. Good morning, everyone. Welcome to the second workshop on Conversational AI. My name is Albert Geramifard. I'm going to do the opening, just warming up and explaining why we're doing this for the second time. And you have a great lineup of speakers that I'm going to go through. So, as you have probably seen, we have now many devices out there. We have Alexa family, we have Microsoft, Facebook just recently joined, Google, Apple, with many devices that they are listening, and we can have conversation with them, making things happen for us, setting a timer, cook you a burrito or something like that. But there is still a gap, and we believe that given all of these assistants out there, there are major challenges. And the goal of this workshop is actually bringing all the people who are interested in these kind of challenges to see how we can tackle them. This is not an exhaustive list, but these are some of the challenges that I think moving forward we need to address them. How about the safety? Like if you have a conversational system talking with millions of people, how we can avoid racism or profanity or things similar to that. Or in terms of metrics, what is a good conversation? You probably have seen a lot of papers talking about blue metrics or Rogue or Meteor or something like that. But at the end of the day, if you're a reviewer, we want to see some concrete human-based metric evaluation that I actually showed it to the people and they say, yes, this is actually better than the other one. But how can we think about like more scalable metrics that they can take into account, maybe engagement or task completion or things similar to that? And the last one, I think it is still an ongoing challenge in terms of context management. You would start talking with one of these systems for a couple of minutes, and then afterwards they just forget what you said. And you have to go back and it's like, oh, I'm actually talking about this specific movie that I just talked about, and why didn't you remember that? So we are trying to figure out this list. Again, it's not exhaustive. I'm sure you guys have a lot of other challenges that you're facing if you're working in this space. We have a great lineup of speakers over here. These are, I would imagine, like 4 of the best people that can actually tell us what's happening in conversational AI systems today. We're going to go through them and invite each of these speakers, but it's fantastic to have them with us today. Let me just touch base a little bit on the paper review process for this year. We had 3 reviewers per paper or more. We tried our best to actually have one academic person be associated with each of the papers. We also made a cognizant decision of making the anonymity optional because some of the folks wanted to also upload to archive. So at the end, we decided to make it optional. As you may know, a lot of the folks over here, they're affiliated with different companies or different research industries or academic settings. So we made sure the conflict of interest is not impacting the review process at all. So anyone who had any ties, we actually asked them to not review any of those papers. And we also made some effort to make sure that not all of the reviewers are from same geographical location. So you have some reviewers from Europe, United States, like around the world. All of the papers are online. If you go to our website, there should be a PDF link associated to any of the papers. If you're interested, you can actually go now and read them. These are some of the stats. So with respect to 2017, we actually see a very good, healthy increase of 60% in terms of the submissions. We decided to increase the amount of contributed talk from you guys. So we increased the number of oral spots from 3 to 6. Poster remained relatively the same. The acceptance rates also was lowered to ensure better quality as we are moving forward, so from 62% to 55%. Oral presentations remained the same in terms of percentage-wise, and we also increased the pool of reviewers. So from 37, we went to 58, which, if you look at it relatively, the same number of submission increase translated to same number of relative increase in the reviewers number. These are the list of reviewers that we had. We were lucky to have all of them helping us. I can't thank them enough. Without them, we couldn't actually give you all the reviewers that you received for the papers. For the first time this year, we're going to have a Best Paper Award. All of the contributed talks are actually nominees for the Best Paper. This year, the prize is going to be actually a set of Oculus devices that we will hand them at the end of the workshop. Jason is going to make that happen, but we are going to announce the results at the end of the workshop. This is the schedule available also on our website. We have 4 sessions. I would just make a couple of quick comments there. Please, if you are presenting a poster, there is Vishnu with an orange shirt over there. he has all of the stickers, so please ask him to give you some stickers, and you can attach your posters all around the room. We will have, after the lunch break, the third session, and then another thing I want to point out is the panel that it starts at 4:30. We have a great set of people actually with a lot of experience in these domains are going to sit down. We will set up chairs over here. If you are interested for a specific question to ask the panel, there is on our website, we have already a forum started. There are questions over there. You can upmark them, or you can start a new conversation or like a new question over there. Feel free to do so. As we getting closer to the panel, we basically look at them and get inspiration from you guys to see what we would ask the panelists. Some last logistics. Invited talks are going to be 25 minutes with 5 minutes Q&A at the end. Contributed talks are going to be 17 minutes with 3 minutes Q&A. I have an iPad over here that if you see it start getting red and the background is red, that means like you're going over time. So we're going to stop you. For poster blitz, if you have a poster, they're numbered from 1 to 17. We would ask you for the poster blitz section to line up from 1 to 17, and we have 1 minute per slide. We discussed, please go to the questions for the panel, hang up posters we discussed, and then finally, we also gonna record all the invited speakers and also contributed speakers. We make them available online for free. It's up to you. If there are forms that Jason has, we are gonna give it to you if you're a speaker to sign it, so we can release the video online for people who wanted to be here today, but for some reason they couldn't, so they have access to all the discussion that we have. I have been fortunate to work with this stellar set of people. Without them, this would not happen. I played a small role compared to everything that happened for this workshop. I would like to thank every single one of them. It was a great inspiration actually working with them and going through last minute reviews, figure out logistics and best paper nominees, contributor talks, and all of that stuff. I personally learned a lot. And finally, thank you for our sponsors, Facebook and Apple, to actually help us record the videos, provide the best paper awards, and basically make this a more enjoyable event for all of us. So with that, I would like to invite Marie to come on the stage. So while you're setting up, I'm going to introduce you as well. This is, I think, the one that you need. So it's my pleasure to introduce Marie Ostendorf. She is an endowed professor of system design methodologies in the electrical and computer engineering department at the University of Washington, as well as associate vice provost for research. She is a fellow of IEEE and ISCA, a Scottish Informatics and Computer Science Alliance distinguished visiting fellow, a former Australian-American Fulbright Scholar and winner of IEEE H.B. Harriet B. Regis Award and IEEE James L. Flanagan Speech and Audio Processing Award. In 2017, as you may know, we have in Amazon, we have Alexa Prize. She was one of the advisors of the winners in 2017, and conversational AI is currently her focus. Her research explores dynamic models for understanding and generating speech and text, particularly in multi-party contexts. Please join me in welcoming Marie.
Thanks very much. It's an honor to be here, and I'm looking forward to the conversation. So I am going to be talking about a team effort, the sounding board team. The work I'm going to talk about is actually post-evaluation, so it's some newer work. And I'm going to focus on one challenge that wasn't mentioned, which is the variation among users. So just to acknowledge the students who do all the work. This is the sounding board team, and in particular, the work that I'm talking about today is going to cover a lot of stuff that Hao Chang, Martin Sapp, and Hao Fong worked on. So as probably many of you know, the Amazon Alexa Prize was a challenge that Amazon posed to students, university students, to build a social bot which could converse with users about any topic. So coherently and engagingly. So it was an open domain problem. And so just to set the stage, what I'm talking about is not a virtual assistant, and it's not a chatbot, in my opinion. And I don't think of these as two different problems. I think of them as two different places in the spectrum of problems in conversational AI. So we have the ability to accomplish tasks. The social bot might, or a conversational system might be more or less social in terms of its interaction. And we think of the social bot as being somewhere in between there. There's not an explicit task like finding a restaurant or booking a flight, but there is an implicit task of helping a user find information and exploring things they're interested in. And there's obviously a social component in the process of doing this. Now, I've placed 2 dimensions here. Obviously, you can think of more dimensions. For example, if it was an embodied agent, then the physical nature of the conversation would also play into it. So the focus I'm going to have today is on user modeling. So why would you want to do user modeling? That should be pretty obvious to anybody who's used a search engine. When you type in a query, a lot of times it starts completing things for you and giving you suggestions. Ads are giving you suggestions. People are trying to get to know you all the time so that they can interact better. And we would like to do this with the conversational system because users' interests vary. Now, in text-based search, personalized query completion or other personalization is based on what's popular, what are lots of people typing, asking for, as well as the sort of thing that you're typing for. In conversational search, these same things can inform us, which they do, but what also informs us is how the person is talking. So not just what they're asking for, but the language itself. That reflects the style and the personality of the person. And that's what we're going to try to get at. Now, if we didn't have to worry about privacy things, I'd also be looking at the prosody and trying to get the audio. So it's how people are talking, not just what they're talking about. So my roadmap here is I'm going to start out with a brief overview of our system and talk a little bit about evaluation and diagnostics, because that's how we got to where we are in terms of figuring out that users are an interesting thing to work on. Plus, as mentioned in the introduction, it's an important challenge. Then I'm going to talk about some characteristics of real users and user modeling, and then some takeaways. So just a brief system overview and comments on diagnostics. So we view our system as a conversational gateway to the web, or a conversational gateway to online content. So the idea with your smart speaker is you could come home and you can, instead of just asking it to play news or play music, you can ask it to play news and then say, okay, what's this website? What are they saying about this? What are my friends saying about this? What is Wikipedia? Tell me what, I haven't heard of this entity. Tell me about it. So you could explore information interactively by voice in the same way you might explore it by text. So just to give you an example of our system, this is an example from the competition. So in this case, users start out, let's chat, and say, hi, this is an Alexa Prize social bot, we're anonymous. And then the user says, I'm 5. Really, they said, I'm fine. We figure that out from the NBest. So we have some chit chat, then we negotiate a subject to talk about. We provide some thoughts about that, we maybe get into a movie sub-dialogue where we've got a little bit more domain information. We leverage IMDb and other sources. And then we might throw in some interesting facts here and there, and that's how the conversation proceeds. So the philosophy that we had in designing the system evolved from having some early bad experiences, like talking about things that were a year old, not good. or not paying attention to what the user was saying. So if you're a good conversationalist, you would have something interesting to say, and you would pay attention to the person you're talking to. So that's the design philosophy. Having something interesting to say means we're content driven. So we do daily content mining. We have a large and dynamic collection, and in order to access this quickly and move from topic to topic, it's structured in a knowledge graph. And we also pay attention to, we leverage information on the web about what's popular and pay attention to that in content ranking. On the user-centric side, what we're doing is in the language understanding aspect, we're trying to pay attention to sentiment and detect engagement. We also have a component that inserts little questions to try to learn user personality. And when we do our generation, we try to make it a little more empathetic to the user's unhappiness or enthusiasm about our system, and we do prosody appropriate grounding. The main system components, it's basically like, most dialogue systems that you would think of. For the understanding system, we have a multidimensional state utterance representation. We didn't at the time get sentence segmentation, so there was a lot of dialogue acts. Multiple intents could be in one conversation turn. So we have different detectors for different types of intents. The dialogue management is hierarchical. We have a master that decides what sort of little mini skills we're going to use, and that's taking into account coherence, and it's taking into account the engagement of the user, whether the user wants to change, whether there seems to be a recognition error, whether there's a lack of content, and then there's all kinds of different mini skills. The response generation is pretty basic. Each response includes a sequence of sub-acts determined by the dialogue manager, and that includes grounding, informing, asking questions for the turn-taking, etc. Okay, so everybody who's worked on these sorts of systems recognizes that evaluation is a challenge. Because we have no explicit task, we can't really measure task success rate. So all our development was based on user ratings, and we were very, very thankful to Amazon for this opportunity because we got ratings from, millions of users. So that was really exciting. But even still, the ratings are, they're sparse. Only 43% of the people chose to rate them. They're noisy. People have a lot of individual differences, mean some people tend to be more open to you and some people aren't, and so there's a huge variation in the ratings. So from our first year, from the final period when our system was better, the ratings were varying from the average was 3.65, and the variance of standard deviation of 1.4 is pretty big. And of course, if we didn't have Amazon, they'd be pretty expensive to collect. So one might think of using conversation length as a proxy. We've found out that it's actually a pretty lousy proxy. It's not a good predictor of user ratings. And most importantly, not all conversation segments are equally good. And in fact, if you map the final rating to all of the conversation segments, it has a pretty low correlation to what hand annotators would do in terms of comparing segments. So what we started doing was using the final conversation score as a weak supervision signal and use that to learn a sequence model of sub-dialogue scores. So you can automatically, from the dialogue manager, track the subtopics and learn a sequence of scores. And that turns out to from the user interaction. So the features are based on how the user is interacting. So what we do is we have a topics, we define dialogue segments based on a topic stack and the system initiation strategy. We learn sub-dialogue scores with this weak supervision way. And then we assess them using the correlation with human rankings of paired subdialogues. So we took two subdialogues from different conversations on the same topic with the same content, so we know we've given the different users the same information to start with, and we had humans rank those subdialogues. So number of turns is not horrible, but the correlation is 0.13. The Oracle conversation score, so let's say I take the final user conversation score and say all subdialogues in that conversation had the same score. That's pretty bad. So this gets back to the point that you can't use the final score to describe everything. Linear regression is not actually all that much better than number of turns. If we use a bi-LSTM, what that is accomplishing is leveraging the fact that different conversation segments will contribute differently to the final score. It should be somewhat, I mean, basically what drove this is the idea is the last interaction is probably the most important. So if you have a really good interaction somewhere in the middle, if you start off bad, you have a good interaction in the middle, but then you end off bad, you're probably going to be bad. So it turns out the beginnings and ends are fairly important. Okay, so now that we have these subdialogue scores, and they're not great, but they're certainly better than the other options, what we can do is we can take all of the conversations and all of the subdialogue scores and aggregate them in different ways. So we can aggregate them according to the topic, according to the source. We could aggregate them in various detail according to the topic. And so we did that, and we learned some interesting things. So first of all, we were pulling from a bunch of places on Reddit. And some of the sources people liked were things that were informative, like Today I Learned. They also liked things that were funny. So the Reddit Shower Thoughts has a lot of funny stuff, and you can come up with things that are like jokes that are topic appropriate. So that was really good. But it turns out that they don't like controversial things such as politics. And even worse, which was a big surprise, people don't like to get advice. So that was our worst subreddit. Then we looked at some topics, and topics that people liked were video games, time travel, aliens, etc. Looking at the bad topics was pretty interesting. It showed us that we had some parsing errors. So, for example, when the topic was the article, we looked for things about article, which was not a good thing to do. It also turned out that people were not so interested in quantum physics. But the other thing that we learned that really stood out to me is if you looked, we were hoping that we could use this to filter topics, to say, oh, this is bad stuff, we don't want to show it to users. In fact, that doesn't work, because some people if you take politics, some people will hate that article, and some people will really like that article. And so filtering based on overall user response wasn't that good because users are different. So that got us into the user variability. So I'm going to go through a few examples, and then I'm going to talk about how we did user modeling. Okay, so users vary in a lot of different dimensions. They have different interests, different topics they're interested in. They have different opinions on things, and they have different senses of humor, which actually matters when you're trying to be funny. They have different interaction styles. Some are terse and some are verbose. I'll give you some nice examples of that. Different goals. Some people are information seeking. Some people like to share opinions. Some people are just plain adversarial. I'll skip those examples. They're not always pleasant. And different ages, which can cause problems for recognition and also the content we're providing. So just to illustrate a fun example about how users vary, it turns out that during the competition, during the finals, it happened over October, where Halloween is big in the US, and so a lot of people were talking about vampires. One of the random things we got about vampires was this quote, did you know that Malaysian vampires are tiny monsters that burrow into people's heads and force them to talk about cats. Now, I actually, when I was playing around it, I got this one too. And I noticed that in looking at, since a lot of people got it, we have a lot of examples, and it had varied responses. Some people are amused. I personally was amused, but some people don't have that same sense of humor, and they were not amused. So what the heck is probably my daughter. And then there's the people who are not really listening. So one of the problems here is if you're trying to tell something funny with a bot, you don't have so much understanding, so you can't quite control the prosody. So, it's sometimes hard to tell a joke if you don't know how to deliver it right. And so in this particular case, some people didn't actually get that it was supposed to be funny. So some people thought it was awesome and very interesting. And lastly, there are the people who are the cat lovers. And this was also a fortuitous thing because it got off into conversations that people really liked. Okay, then here's an illustration of style. These are all real examples. This is a talkative user. This is an excellent example of a talkative user, also during the vampire season. And this user wanted to tell us what she knew about, or he knew about vampires, and asked lots of deep questions about vampires, like, is it really true that garlic keeps vampires the wedding, and this is also illustrating that talkative users tend to be harder to recognize. Then there are the terse users. This is an actual conversation. This is the actual sequence of what this person said. Only about half of it. They went on for a pretty long time saying, yeah, no, sure, yeah. Occasionally we get a cool. So what these illustrate is, first of all, talkative users are difficult for recognition and understanding. But they do offer the potential to learn more about the user. Terse users are difficult. Their recognition is easier, but it's difficult to learn much about them. Okay, there's different user-seeking goals. So for example, tell me more, what is that? Then so tell me more is great, you just keep talking, but why? That's a tough one. So one of the challenges in these situations is you have to understand not only the user, but you actually have to do some understanding of the content you're talking about. There's opinion sharing, getting to know each other. Opinion sharing is also a pretty tough one from an understanding point of view. Then, because we did this personality quiz, we have personality ratings, and the questions were modifications of the Big Five, and they're not exactly the Big Five, and of course people can lie, but it's interesting, the results we get make sense, and I know from my experience in watching other people interact with the personality questions, the first time that you answer, the questions are probably reasonable, you're probably somewhat honest. The second time you're playing around with it, and you're trying to see okay, if I change my personality, what answer will I get? Because we give them a Disney character at the end. But the first time, it's actually pretty reasonable. And so what we find is personality correlates with user ratings. Extroverts and agreeable people like us more, not surprising. And the topics brought up by users tend to be correlated with their personality. So introverts, like AI, food, cats. Extroverts, like news and fashion. Open and imaginative people like AI, time travel, etc. My favorite is low conscientiousness people. As I tell my students, these are the people who are a little bit last minute on their homework. They like Pokemon, video games, and Minecraft. Okay, so the implications for this are for all components of the dialogue system. It affects ASR and language understanding. It affects our content ranking and dialogue management, what we filter in content management. and the politeness, et cetera, in terms of our response. So rather than tell you how we use it, because we're just starting to detect it, what I'll do next is talk about how we actually learn about the user. So what we're working on is the content ranking problem. So, or one can think of it as content recommendation. So the idea here is, given the user's responses so far, we want to rank candidate content that's related to the topic, okay? Or we want to rank possibly new topics that we want to suggest. So we want to take into account, what we're already taking into account was topic coherence and topic popularity, but that was overall popularity. Like if you pull something from Reddit, you got karma. If you pull something from a news source, you may have likes. So that's the general popularity. What we want to do now is bring in user characteristics and interests. So what are the things that they have engaged with so far or rejected, but also how they're talking. So there's two different components. Now, in order to do this with our existing dialogues that we're training from, as opposed to do it real time with new users, what we did was take the problem and cast it can I predict whether they would accept, whether the user would accept or reject topics that were offered. So that's the problem that we're solving here. So as an example, the system might say, do you like the actor Arnold Schwarzenegger? The user said, this is an actual example, yeah, before he got into politics. And so the issue would be, how am I going to respond after that? So the challenge here, if we want to take the user information and the topic information, that's very sparse, particularly because we don't have any user information for privacy reasons. So there's no metadata. We don't even have the time zone. We have no audio. And the multiple people in a family use these devices. So what we're doing is we only have one conversation. So the fact that we get a gain, just wanted to warn you, I know we should have more, but we don't. And the fact that we get a gain from this little is actually pretty good. Although we've restricted it to conversations that have more than 5 turns. So what we do, because things are sparse, we're going to have to map things to dense embeddings. So we'll map topics to an embedding using one approach and users to an embedding using another approach. So the topic is going to be reflected by words in the content. The user embedding is reflected by words that the user says. Now the user model is effectively a context-dependent language model. There's different options, sequence to sequence, what we explore is basis vectors plus attention, and then that goes to a sequence, and that turns out to work better. So just to try to finish up quickly, so the scenario is to accept or reject topics, no cross-conversation history, just using the first 5 turns. A strong baseline is overall population. What did people like or dislike this topic? Adding the user topic acceptance rejection improves it just in 5 turns. So that's like you're not learning much, but adding the user language further improves it. And then as we sequentially update it, we get better results. So here's my cherry-picked example, admittedly. So in this particular case, we say, super, would you like to know a fun fact about Arnold Schwarzenegger? And the person says, why not? Sure. So that's accepted. So then later on, the conversation goes on and it says, I'm running out of things to say about him. Do you want to hear some news about politics? So the person says no. It's rejected. So the idea is we want to change this so that the system is leveraging the fact that, before he got into politics means the person doesn't like politics, and learn not to make that suggestion. And in fact, this is an example where our system, the new version, does the right thing and does not suggest politics. Okay, so what do we learn from the user vectors? Because of using these basis vectors, we can map them back to different categories of language use. And we actually can learn something in a similar way to to what you might do with LDA. And we compared it to LDA. It works much better than LDA. But you actually turn out to learn similar things. So you learn things about ways people interact with certain modes of the system. Some users are polite, some are sort of self-oriented. You learn when there's positive engagement, there's a series of words. Some people humanize the bots. And there's a mode that's related to video games. So it's sort of popular. Okay, so just to summarize, a few takeaways. I didn't actually explicitly say this, but I want to end with this, emphasizing this. When you have social conversation, and particularly when you're doing information exploration, it really brings out the user variations. And I think on top of that, the fact that our speech recognition has gotten so much better and language understanding is better, as the systems get better, people are more comfortable with talking to it in a human-like way, and it brings out user variation. So I think this user variation issue is going to be increasingly important as we get more conversational. Secondly, just to point out that understanding the user includes both what they said, the intent and the sentiment, but also the language of how they're talking, because it tells you about the personality, and that tells you about sort of the way they're going to react, whether they're opinion sharing, whether they like certain topics, etc. And finally, user modeling has implications for all of the different dialogue components. I haven't looked at how I'm going to solve that problem yet. We're just trying to find the user information and focusing on the content recommendation. But it does impact all of those components, but it also impacts evaluation. So we know that certain people are going to give us better ratings, and you want to take that into account in thinking about your system. Okay, with that, I will give credit again to the students. Thank you. So
Yeah, I can repeat the question. Could you detect topics that felt uncomfortable from the user's perspective?
So this is part of the engagement detection. So we have positive engagement, and we have a couple different dimensions of engagement detection, and so we are trying to get at that. So whether so there's positive, they like something. That one of the things that's really tricky is when somebody says, "Oh, that's awful." Sometimes it's a sympathetic, "Oh, that's awful," and sometimes is they don't want to hear about it. Right? And those sorts of things we currently can't distinguish between because we don't have the audio.
Thank you.
One more. This is the last one.
Thanks, Mari, for a great talk as usual. I'm just wondering if you could just summarize the dimensions along which you actually would try to categorize the users. So you mentioned the topics and then also the sentiments towards the topics. Are those the only dimensions, or were there other things that you also were trying to learn about the users?
So we have two subvectors. One subvector is topics, and what that is we have, so for each topic you can learn an embedding. So the topic is actually associated with content. So you have the topic word. So we have two levels of things. We have the topic word, and then we have the actual content. And those you can learn embeddings with standard bag of words, sorts of things. And we have topics that were accepted by the users. So we have a subvector for topics that were accepted and a subvector for topics that were rejected. The next future work is making that more fine-grained and looking at engagement as opposed to explicit acceptance and rejection. The second subvector is the user vector. And we are implicitly capturing things like positive engagement. But what we're doing is, and this is where by representing these basis vectors, they're neural basis vectors, so you learn these basis vectors, and so the user, each utterance is a weighted combination of these basis vectors, and then you can map them back. So we're implicitly learning these different modes. So part of what we're learning is positive engagement or negative engagement. Part of what we're learning is more things about the speaker that we didn't explicitly hand engineer. We're just learning it as latent vectors.
Well, let's thank Maria again.